Everybody ready? All right, this is going to be our last thing that we do. This is the end of section 5.5. We already did one. We already did one yesterday on 5.5, but we're going to finish this up. So let me just review something real quick with you. Don't want red. Okay. Did we talk in here about taking the log of a negative number? I think I might. Did we talk about it? And tell me something about it then. You can't do it. Okay, good. We have talked about it. I just couldn't remember if we had or not. That's going to come into play here. All right, so just kind of remember that in the back of your head once we get to the end of these problems. All right. So I was just going to check with you just to make sure that we did. And let me find a good problem here to do. All right, let's do this one right here. Again, we're solving for x, just like we did earlier. But these are a little bit different. We're going to use the same rules. Remember the product rule, the quotient rule, right? We've used the power rule a ton, but we're going to use that product rule and quotient rule to be able to solve for x. So this is log base a of x plus 6 minus log base a of x plus 2 equals log base a of x. All right, there's the problem. Looks kind of familiar, doesn't it? You got a log and a minus here. I just don't think that we have actually solved for x before. I think when we did this stuff, all we did was change it from, the subtraction to a single logarithm. Remember those problems where it said, change it to a single logarithm written as a product or a quotient? Yes? No? Okay. Yeah. But this time, we're actually solving for x. They haven't asked us to do that with this style of problem, with these equations, I guess you can call them. All right, but now we're actually going to solve for x, and we're going to use this thing. We're going to use it to actually find what x is equal to. All right, so you see a subtraction, you see a log here and a log here. What does that tell you? Subtraction tells you, with logarithms, you're going to divide. Good. So you're just going to have one single logarithm out in front. All right, so there's our single logarithm, and you're going to divide. You're going to divide this one by this one. So it's going to be x plus 6 over x plus 2 equals over here, log base a of x. So that was the rule. All right, that's the quotient rule. All right, we take subtraction, turn it into division. Now look at this. They actually made this kind of easy. Log base a of this equals log base a of this. Can't remember if it was in this class or the Algebra 2 class. I know I say this all the time, but the log of this equals the log of that, so this equals that. You ever hear that before? Okay. I've said that. Have I said that in here before? Okay, so yeah, the log of this one equals the log of that one, so this one equals that one. All right, so really, basically, what just happens here?
Logs,
yeah, the logs just go away. So now we have this thing, and now we just have to solve for x. Because if I said, watch, if I took log base a of x equals log base a of, 2, what's x equal to? If they're equal to each other, right? This has to be a 2, right? Log base a of 2 equals log base a of 2. Log 6? No, I said a. It might look like a 6. I don't know. I've said a every single time I said this log base a. So anyway, watch. If this log base a of something equals log base a of something else, then those two things are going to be equal to each other. You see that? Because this has to be a 2 for them to be equal. Couldn't be a 3, couldn't be a 7. It's got to be a 2 for that to be equal. So basically, in effect, they kind of go away, don't they? We applied the same exact rule here. So log base a of this stuff right here equals log base a of this right here. So basically, this thing and this thing have to be the same. And that's what we're going to do right here. We're going to set them equal to each other. Okay? Now we're done with logarithms, aren't we? Now it's just a matter of solving for x. So what in the world would you do here to solve for x? Does 2 go into 6 right there? Can you do that?
No.
Can you cancel out the x's? No, because you got pluses, pluses. Addition in between them, okay? So what do? I don't like this denominator, do you? I like stuff all on one line. That's what I like. So let's get rid of this and say it, Sarah.
Multiply.
Yeah, multiply both sides by x plus 2. So let's do that. If I multiply the left side, that's going to go away. Then I got to multiply the right side. So this is what we're going to end up with. We're going to go x plus 6 equals, watch, I'm going to multiply by x plus 2, and I'm going to do the same thing over here. So what's that going to be? X times x plus 2. You with me? Now it's starting to look like a quadratic, isn't it? Do you see it before it's actually a quadratic? Okay, so it's x plus 6 equals, what's this? X squared plus 2x. Now it is a quadratic, so we're going to put them equal to 0. Catching all this, Justin? So x squared plus 2x, but let's put this stuff over here on the right-hand side since x squared is already positive over here. So we subtract an x and we subtract a 6. So let's write it. X squared plus what? X minus 6 equals 0. I should have put equals 0 right there. Equals 0. Now let's move this up here. What do you think? How in the world do we solve this? There's a couple ways.
Negative 2 and 3 factors.
Yeah, I always look to see if it factors first. Now they don't always factor, okay? But I always look to see if it factors first. You could go straight to the what? And solve every single time.
Quadratic equation.
Yeah, formula. Quadratic formula, right. I could go to that every time if I wanted to. But man, sometimes if it factors real nice, it's just so much quicker and easier to do it that way. So I put an x here and an x here. Now look at what you're trying to do. What multiplies to be negative 6, and at the same time, the same two numbers have to add up to positive 1. What two numbers do that?
Negative 2 and 3.
Yeah, positive 3 and negative 2. Does that work? Sure. When I multiply those two together, I get negative 6. When I add them together, I get a positive 1. That's basically just the backwards of the FOIL method, isn't it? If I FOILed this, I would get to this thing right here. Now, what do we do to both of these things? Good. Alright, set them equal to 0, so x equals what? Negative 3, and x equals what? Positive 2. Alright? Now, what do we have to do, though? We can't just circle them. Remember what the first thing I said at the beginning of this lesson? I asked you, did we cover it? And you're like, oh yeah, we covered it, and you told me something. You can't have the log of a negative number, that's right. Look back at the original problem. Okay? This thing right here, I even got an arrow there, this whole thing right there, they call that the argument of the logarithm, all right? The argument. It's basically whatever you take in the log of, all right? The log of what? That's called the argument. Now, the argument always has to be positive because you can't take the log of a negative number. So watch, if I stuck a negative 3 in there, negative 3 plus 6 is 3, that's fine. That's still a positive number, isn't it? Okay, what about 2? Put a 2 in there. 2 plus 6 is 8. Sure, I can take the log of 8. That's no problem. What about this, though? What if I put both those numbers in that? I can't put what?
Negative 3.
The negative 3. I can't put a negative 3 in here because negative 3 plus 2 is going to be a negative 1. I can't take the log of a negative number. So that alone tells me I can't use negative 3. Also right here, I can't put a negative 3 right here because that would make that the log of a negative number. So you always have to check. When you do these things, you always got to take a look at your answer. You got to say, hey, if I put it in for x, will I get a positive argument? Well, I won't with negative 3. With 2, I'm fine. It works every single one of these, doesn't it? All right, and it has to work in all of them for this to work. So now I can circle 2. I'm good to go, and that's my answer. Question?
So if you had x minus 6 for the first one instead of x plus 6, the 2 wouldn't work either.
Right, exactly. Yeah, sometimes neither one of them work.
Okay.
Right. Sometimes both of them work. Sometimes one works. Say what? You just say no solution, right? Sometimes none of them work. You say no solution. Sometimes one works. You circle that one. Sometimes they both work. All right, so you would circle them both, and you get 2 answers. We good with that? All right, let's move on. All right, let's write this down. Actually, hold on. All right, here's the last example. It kind of looks like the beginning of the other one, doesn't it? You got a minus here, and you got logs out in front. Now, this is a log, but it's a what kind of log? It's a natural log, okay? Let me see something real quick. Let's do this. Hang on just a second. All right, now we got it worked out. Watch this. Before we even do that division thing, check this out. See the natural log of e? That's kind of the same thing as saying log base e of e. What happens when you have something like that? They just cancel out, and you're just left with whatever your exponent is, correct? So check this out. This is log base e of e, isn't it? Because that's a natural log. So that just goes right there. What are we left with? Just that. So now, instead of writing it real crazy like that, I can just write natural log of x minus natural log of x minus 3 equals natural log of 2. So watch. One natural log out in front. We do a division. X minus 3 equals natural log of 2. Simple. What happens? Natural logs go. Let's do some math. Same math that we did the other problem. multiplied by x minus 3. So x equals 2 times x minus 3. Now we just solve for x. No quadratic here, that's nice. Minus 6. Subtract an x, add a 6, so x is 6, and we're done. And that's it.
That's pretty easy.
Yes, that one was easier. You'd think that the examples get harder as they go on, but that one was actually pretty easy. That was a nice little step, though, right here, wasn't it?
Yeah.
I mean, that really helped us out, made it a lot easier. So look for that kind of stuff. E is the log base of E is the same thing as ln. Okay, that's what it means. It's just another way, quicker way to write it. All right, that's it. That's the last new lesson of the year ever in high school. How about that? It's historic. All right, say bye, everybody. Say bye.
Bye.